Okay, so our next question is prime number, and it is more interesting problem because it has a brute force solution, a better solution and an optimized solution. And this problem is important for the interviews as well. We are going to see all three of them. Let's kick this title first and try to look at the brute force solution. Okay, so what is a prime number? Let's say we have a number n equal to 5, and a prime number is a number which is divisible by 1 and the number itself. So we know that 5 is a prime number and it has only two factors, 1 and 5, right? But how do we programmatically solve this problem? Okay, let's look at this. Now we have numbers like 1, then we have 2, then we have number 3, 4 and 5. Now before 1 and after 5, we know that there are no factors of 5, right? That is, there are no numbers which will divide this number 5. That's what we are interested in, right? Now after this 1, because we know that 1 and 5 are the obvious factors of this 5 or any number that is there, right? Let's take about 7, let's take the number 8. The 1 and the number 8 which will be the obvious factors. Okay, now after this 1, that is always starting from 2 and 1 less than the given number, 4 in our case. Okay, we will look at this section. Okay, now let's start with 2. We will check if 5 divided by 2 is possible. No, it is not possible. Then we will move forward. Then we will check if 5 divided by 3 is possible. No, it is not possible. Then we will move forward. Then we will check if 5 divided by 4 is possible. No, it is not. So at last we came into conclusion that the 1 and the 5 are the only factors which are dividing this number 5. That's why 5 is a prime number. Now let's solve this question by keeping these things in mind. Let's look at the pseudocode. We have n equal to 5. Okay, this is predefined number, but it can also be a user input. What we will do, we will add a for loop. Now I hope that you know about for loop and all the basic syntax of C++, okay, or any other programming language that you are working on. So what we will do, we will start from 2, int I equal to 2. Let's delete this int where we are just looking pseudocode. We'll start from I equal to 2. We will go up till 1 less than the number 5, that is n in our case. Okay, so this will start from 2 and end with 4, and let's do this y++. Now what we need to do, we will check if my number 5 is getting divided by the I number that we have. Now any number which is dividing this 5, that will not be a prime number. Okay, so we can simply say not a prime number. Okay, and we will break from it. Now at last we can simply say cout the number is prime. But what will happen here after this statement? Let's say this statement executes and this statement also executes. Okay, and this will be printed out. Okay, not a prime number. And after this break statement, it will come out of a for loop and it will also print number is prime. So we need a checker where we can check that this statement, this code block is executed and we don't want to print this. Okay, so we will take one flag here, flag equal to 0 for the first time. Okay, and here what we can do, we can check this flag equal to 1. We will do one thing, that is if my flag is still 0. Okay, so what does it mean? This code block is never executed. That's why the number is prime number. So we can simply print this number is prime. Otherwise this code, that is this code statement, is printed. Okay, now let's look at the better solution that we had. So we had this number n equal to 11, and for every number after this say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So after this 2 and until this 10, we were checking the numbers in the first time. Now we are reducing the numbers up to 11 divided by 2, the floor division. Okay, because we know that after 6 there is no possibility that this 11 occurs in a table. That is, after this, all these numbers are not the factors of this 11. So there is no sense of checking these numbers again, right? So we will check up to 5. We will take the higher number that we have. Okay, so let's take n equal to 17. Okay, now we will have these numbers 1, 2, 3, 4, 5. Okay, now for the better solution that we had, we know that this 1 and this 17 are skipped. Okay, and what is 17 by 2? 2 8 is 16. So 17 by 2 is 8 in the floor division. So up till this 8, we will need to check, because 9 2s are 18, which is greater than 17. So there is no possibility that this 17 exists in the tables of all these numbers. For the better solution, that what we used to do, we used to check for 2, 3, 4 and all these numbers. Now we want to reduce the time again. So how do we do it? Now we know that 4 is what? 4 is what? 2 into 2. 6 is what? 2 into 3, right? 5 and 7 are already there, right? 8 is what? 4 into 2. That is 2 into 2 into 2. Okay. Now for every number, let's say we have checked for 2. Okay. Now we have checked for 2. Let's say 2 here. And we know that the given number is not divided by 2. Okay. What we will do, we will check for 3. We know that this number 17 is not divided by 3. Now we came to 4. Now let's break down 4 here. What is 4? 2 into 2. We checked for 2. We again check for 2. So this number is not in a table of 2. Then there is no possibility that the multiplications of it, let's say the 4, will not contain the 17. We know that this 17 doesn't occur in a table of 2. It is not getting divided by 2. So 2 into 2 is 4. So there is no possibility that this 4 also gets divided by 17. There is no possibility at all. Now similarly, we checked for 2, we checked for 3. So there is no possibility that this 6 is the factor of 17, because 2 is not a factor, 3 is not a factor, so 6 is also not a factor. Similarly, it will go for 8. Let's say we have checked for 2, we have checked for 3. Now 4 is 2 into 2. We don't need to check, because we know that 4 is not a factor. We will check for 5. We will not check for 6. Right, because 2 into 3 we have checked for 2, 3 and 6 is not a factor. Then we will check for 7, because it doesn't have a factor, and we will not check for it. Okay, so what are we doing here? For every section we are reducing the time to again half, that is root times the number. So this 1, 2, 3 and 4. So what we are doing, we just need to do one thing, that is root of n, square root of n. This is the logic. Now let's try to look at the pseudocode. Okay, now let's look at the pseudocode. We have number n equal to 17. Okay, what we will do, we will have a loop. Okay, for I equal to 2, and here what we will do I is less than equal to square root of n. This is not the case how you write the square root. I am just writing it for the pseudocode purpose, right? I plus plus, and here we will check if the process is same. If n is I, we just need to check if I is the factor of n or not. Okay, and here what we will do, same process. Flag equal to 0, then we will print that number is not prime. Okay, we will set that flag to 1 and will break. Okay, and we will check if flag is still 0, then we will print number is prime. Okay, I hope you got the logic of 3 solutions: brute, better and optimize. Now let's look at the actual code. Okay, thanks. Okay, now let's do the code for prime number. Here I have defined 2 variables, number and flag. Number for taking user from the input, and flag for actually checking whether the given input is a variable, that is a prime number or not. Okay, so here I have taken input from the user, and then we will check if the number is less than or equal to 1. See, negative numbers and 1 are not prime numbers. Okay, so every number starting from 2 can be a possible prime number. So here I have set that flag to false, because we know that the number is not a prime number, and then we will print cout not a prime number. Okay, so you can actually adjust these printing statements according to your own choice. Okay, and in the else block, what we will do, we will run a loop for I equal to 2 to I equal to the number that we have. Okay, and we will check if my number is divisible by I or not. Okay, the reason why we are not considering the number itself is because we know that the number is divisible by 1 and that number itself. Okay, so the condition will fail. That's why we will start from 2 and then we will go to the number 1 less than the input number that we have. Okay, so I less than number, let's say we have 5. So if I write I less than 5, it will go up to 4. Okay, that's what we want. So here we will check if number percent I equal to 0. That means if that number is divisible by I or not, then we will set to float. See, if it is divisible, then we can say that the number is not a prime number. Then we will set flag equal to false and then we will print the it's not a prime number. Okay, and we will break from it. We will break from it because we know that the number is not prime number. We don't need to check for rest of the numbers. Here at last we will check if my flag is still true. If my flag is still true, then I can print the given number is a prime number. Okay, and this code is perfectly fine. Let's execute it. So I will create a problem here and let's see, we have given 3 number. Okay, so 3 is a prime number. So we got prime number here. Let's check for 6. 6 is not a prime number. It's a even number. So it's not a prime number. Okay, and when we gave something like 1 input, 1 is not a prime number. Okay, so it's working perfectly, but this is not optimized version. This is something brute force approach. Okay, because it is executing big of n times. Okay, now what we need to do, we will optimize it further. And when we know that if we added, let me write another approach here. Okay, so let's write here approach 1. Okay, similarly what I will do, I will copy this and I'll comment it out. Then at the bottom I will print the second approach. Let's talk about second approach. That is going up to the number by 2, going up to less than or equal to. We will consider that number as well. Okay, and we will check, we will do the exact same thing. The process is same, but we will go up to the number less than 2, because we know that after every number, the number that we are actually checking will not be divisible. So we don't need to check. Okay, so let me execute it once again. So 1 is not a prime number, but when you give a number, let's say 15 is not a prime number, so it gave 15 is not a prime number. Let's give something like 13 is a prime number. Okay, so we got 13 as a prime number. So this is a better version. Now let's talk about the third approach. And let me do the same. I will paste that, comment it out. Okay, so this is the third approach. So for third approach, we will go up to square root of n. Square root of the number that I have. Let's say number was there, right? Okay, number was there. Okay, and I think I will have to import the math library also. So let us include math library. C math or math was there, I don't know. I guess C math library was there. Okay, sure. So we will go up to square root of number and okay, now I have written square root of number. Now let's try to execute this code. Okay, so if I give the 13 input, 13 is the prime number, so it gave prime number. Okay, and if you give something like 20 is not a prime number, it will give not a prime number. So this is the optimized approach. Okay, so thanks for watching this video. Now it's your time to do the code.